Hello friends, in this video we are going to discuss Coulomb's law in vector form. Coulomb's law in vector form. Till now we have studied the Coulomb's law to find the magnitude of the electrostatic force between 2-point charges. So if you are given 2-point charges Q1 and Q2 separated by a distance r, you can easily find out the electrostatic force Fe between 2-point charges. The magnitude of the electrostatic force between 2-point charges is given by 1 by 4 pi epsilon naught mod q1 mod q2 upon r square. But friends, because force is a vector quantity and we have to find both magnitude as well as direction. Therefore, we have to study Coulomb's law in vector form. Okay. So let us take two charges Q1 and Q2. Suppose there is a charge Q1 and this is charge Q2. Two charges are there, Q1 and Q2. Q1 is placed at point A and Q2 is placed at point B. Right. Let us suppose the position vector of this point charge Q1 is this one, and suppose this is R1, and the position vector of point charge Q2 is R2. Okay. Now we have to find and suppose this is the x-axis and this is the y-axis. We have to find the Coulomb's law in vector form. We have to find the electrostatic force between 2-point charges Q1 and Q2. We have to find the magnitude of the force and also the direction of the force. Let us suppose both the charges are positive, for example. Okay. So first of all, let us find out the force on charge Q2 due to charge Q1. Initially, we will find out the magnitude of the force. Okay. So the force on charge Q2 due to charge Q1 is denoted as F21. F21. It is the force between. It is the force on charge Q2 due to Q1, and the F12 is the force on charge Q1 due to Q2. Now we are going to find out both F21 as well as F12. So let us find them one by one. Okay. So let us find first the magnitude of the force on charge Q2 due to charge Q1. So according to Coulomb's law, it will be 1 by 4 pi epsilon naught mod q1 mod q2 upon this distance AB. So let us call it AB square. Okay. Now because this is positive and this is positive, so this charge is going to repel this charge in this direction. This charge Q1 will repel Q2 towards right, that is from A to B. So direction of the force on this charge will be from A to B in this direction. Okay. So to attach some direction to this force, to this magnitude, let us multiply this magnitude by the unit vector of this AB. This AB. So unit vector, if we multiply this magnitude by unit vector of AB, we can find the direction of the force, and this becomes the vector form of Coulomb's law. Okay. So vector form of force on this charge Q2 due to charge Q1 will be this one. Okay. So this becomes the magnitude part and this becomes the direction of pass, direction part. So you have already studied in your 11th class what is a unit vector? A unit vector means a vector having unit magnitude and a particular direction. The role of unit vector is to attach some direction to a scalar quantity. Okay. Suppose if we multiply, suppose I have 2. If I multiply it by 2 I cap. Okay, if multiply by 2, if 2 is multiplied by vector I cap, that means we are going to travel distance 2, or you can say we have some magnitude 2 in x direction, positive x direction, right? So similarly, to give some direction to this force on this charge Q2 due to charge Q1, let us multiply it by the unit vector of vector AB. Okay. So now you know that you have studied in your 11th class that there is a law that is known as triangle law of vector addition, which states that if any two vectors A and B, suppose this is vector A and this is vector B, If any two vectors A and B are represented in magnitude and direction by two sides of a triangle in same order, then the resultant will be represented by the third side of that triangle in opposite order. So this is the resultant. Here you can see, because force is acting in this direction. So this becomes R1, this becomes this AB. So if you see here, this is R1, this is AB. So R1 vector using triangle law, R1 vector plus AB vector will give you is equal to vector R2. Or you can say OA vector plus AB vector is equal to OB vector. So AB vector, that is displacement vector from A to B, was OB minus OA. Or you can write it as the position vector of final point B minus initial vector of position vector of initial point A, and you can write it as R2 minus R1. Right. Similarly, so we can find the vector AB. Let us find vector AB. So you can write here 1 by 4 pi epsilon naught mod q1 mod q2 upon AB square. So AB becomes R2 minus R1 square. Okay, and this becomes AB unit vector of AB means vector AB divided by its magnitude. So we can write 1 by 4 pi epsilon naught mod q1 mod q2 upon R2 minus R1 square, and this becomes R2 minus R1 upon the magnitude of R2 minus R1. So finally we can write this q1 mod q2 upon R2 minus R1 whole cube, and this is R2 minus R1. Okay, in short we can write it as 1 by 4 pi epsilon naught mod q1 mod q2 upon, because R2 minus R1 is a vector AB going from A to B. So direction of this is from Q1 to Q2. So R2 minus R1 we can write as R12 whole cube, and this is R12 vector whose direction is from charge Q1 to charge Q2. So dear friends, this is Coulomb's law in vector form. In this way we can find the force, the magnitude and direction of the force on charge Q2 due to charge Q1. Similarly, now we can find the force on charge Q1 due to charge Q2. Okay. So if we find the force on charge Q1 due to charge Q2, that is F12. So we can write 1 by 4 pi epsilon naught mod Q1 mod Q2 upon the direction of this force will be from B to A. So this charge will repel this Q1 in this direction. So the direction of force will be in the direction of vector BA. So we will write it as BA square. Okay. So this becomes the magnitude part of the force on charge Q1 due to charge Q2. So if we want to attach some direction to it, we have to multiply it by unit vector of BA. Right. So now it becomes 1 by 4 pi epsilon naught mod Q1 mod Q2 upon, this becomes BA square of any vector, is the square of its magnitude. So we can write it as mod BA square, and we can write it as BA vector upon the magnitude of BA. Okay, BA vector upon magnitude of BA. Right. So now if we can, from here we can see that what is BA. So from triangle law, OB and BA vector will be is equal to the position vector of final point A, that is OA, minus position vector of initial point B, that is OB. OA minus OB, and OA was R1 and OB was R2. So BA vector becomes R1 minus R2. So you can write here 1 by 4 pi epsilon naught mod q1 mod q2 upon r1 minus r2 mod whole cube, and this becomes r1 minus r2 upon the magnitude of r1 minus r2. Okay, so now we can write as force on charge q1 due to charge q2 becomes 1 by 4 pi epsilon naught mod q1 mod q2 upon r1 minus r2 mod whole cube, and this is multiplied by r1 vector minus r2 vector. In short, we can write it as 1 by 4 pi epsilon naught mod q1 mod q2 upon r, this vector is from charge q2 to charge q1, r1 minus r2 vector, that is ba vector, is from point b to point a, that is we can write as r21. r1 minus r2 can be written as r21, so r21 cube, and this becomes r21 vector. Okay, so now this becomes the force on charge q1 due to charge q2. Now we have the formula for the force on the two charges. So this is nothing but Coulomb's law in vector form. In this way we can write Coulomb's law in vector form. Okay, so now if we compare these two forces, that is F12 and F21. F21 was, I remind you, F21 was 1 by 4 pi epsilon naught mod q1 mod q2 upon r12 cube, and this becomes r12 vector. So now if we compare these two forces, F12 and F21, you can see that this part is same, this is same in both these forces, and the magnitude q1 q2 is also same in both the forces, and R21 mod is equal to R12 mod, because magnitude of a vector means length of the vector. So length is going to remain same. If either you take it from A to B or B to A, the length will remain same. Okay, so R21 mod is equal to R12 mod. So this part, the magnitude part in both the forces will remain same. This is same in both the forces. But if we see this R21 and R12 vector, because the direction of R21 vector is from 2 to 1 and R12 vector is from A to B, you can say 1 to 2. So that the difference lies in the direction. That means R21 vector is equal to minus R12 vector. So from this we can see that this magnitude part is same in both the forces, but direction part is different. That means this implies that force on charge q1 will be equal and opposite to the force on charge q2 due to charge q1. Hence the two charges q1 and q2 exert equal and opposite force on each other. Whatever be their magnitudes, the force exerted by the charges on each other are equal and opposite. From here we can conclude that conclusion comes out that Coulomb's law also obeys Newton's third law of motion. What was Newton's third law of motion? To every action there is always equal and opposite reaction. So Coulomb's law obeys Newton's third law of motion. If I ask you, there are two charges, 1 microcoulomb and other one is 100 microcoulomb, separated by distance r. So which one will exert greater force on the other? So answer will be both of the charges will exert equal force on each other, but in opposite direction. Okay, so this is Coulomb's law in vector form. Okay, now we will discuss limitations of Coulomb's law. Limitations of Coulomb's law. Dear friends, this Coulomb's law is not applicable everywhere. Okay, it has some limitations. So there are basically two limitations of this law. Number one, that this law it is valid or applicable only for point charges. It is valid or applicable only for point charges. So using this law you can find the electrostatic force between to point charges only. So point charges means you can say that the charges whose magnitude is small, or you can say in comparison to their distance between them. So the magnitude of the charges should be small in comparison to the distance between them. Okay. So this law is applicable only for point charges. So if the magnitude of the charges is large, so they should be kept you can say at a considerable distance, so that they can be called as point charges, right? So otherwise charges should be small as possible. Okay. So it is valid only for point charges. Second limitation of this Coulomb's law is that it is not valid for very large distances. It is not valid for very large distances, such as in kilometers. So suppose if two charges are separated by distance of 1 kilometer, 2 kilometer, in that case also you cannot apply Coulomb's law to find the electrostatic force. You need not apply that law. Okay. So and also not valid for very small distances. It is not valid for very small distances, such as nuclear dimensions. For example, if the distance between the two charges is you can say even less than 10 to the power minus 14 meter, which is nuclear dimension, nuclear you can say radius. So the nuclear radius is of the order of this much, 10 to the power minus 14 meter. So to find if the two charges are there, suppose this is 2 microcoulomb charge and another one is 6 microcoulomb charge, and they are separated by distance of 10 to the power minus 16 meter. If the distance between the two charges is this much, which is less than this nuclear dimension, so in this case also you need not apply the Coulomb's law to find the electrostatic force between 2 point charges. So these are the two limitations of Coulomb's law. Okay. So hope you like this video, dear friends. So if you like it, so please share it and see it again and again. Thank you so much.